Suppose a pug walks 2 meters east. We could represent the pug's displacement with an arrow, and we're going to have it pointing to the right because we usually take to the right to mean east and to the left to mean west. Now suppose a beagle walks 4 meters east. I could represent the beagle's displacement by also drawing an arrow pointing to the right but making it twice as long. Pug walked 2 meters and the beagle walked 4 meters. These arrows that I just drew are graphical representations of vectors. Remember that a vector has a magnitude and a direction. That means it has a length and an arrowhead to indicate direction. So when drawing vectors, the arrowhead indicates the direction and the length of the vector indicates the magnitude. Now from my pug that walked 2 meters east, obviously I didn't draw an arrow 2 meters long. I just drew an arrow of reasonable length, and then when I had the beagle walking 4 meters east, I made sure to make the beagle's arrow twice as long. In other words, I just want to keep things in check proportionally. For example, suppose I have a golden retriever walking 1 meter west. Well, then I'm going to have it point to the left, and I'm going to have it be half as long as the pug's arrow, and a fourth as long as the beagle's arrow. Sometimes we use a scale to indicate the magnitude. For instance, maybe 1 centimeter equals 4 meters. So that if I have a bulldog walking 20 meters south, I would want to draw a line 5 centimeters long pointing down. In other words, since 1 centimeter is equivalent to 4 meters, 5 centimeters is equivalent to 20 meters. But what if I don't have a nice number like 20? What if instead I have a poodle that's walking 6.2 meters west? That's okay, I can set up a ratio. 1 centimeter is to 4 meters as x centimeters is to 6.2 meters. Now I can cross multiply, so I get 4 meters times x equals 1 centimeter times 6.2 meters. And then divide both sides by 4 meters, and I have x equals 1 centimeter times 6.2 meters divided by 4 meters. And notice that the meters cancel and I'm left with centimeters, which is what I want. And this is 1.55 centimeters. So for the poodle's displacement, I would draw an arrow pointing to the left, 1.55 centimeters long. When drawing vectors, you can move them around wherever you want, as long as you don't change the length and you don't change the orientation. So for example, a schnauzer walks 3 meters south. Some examples of correct ways to draw this vector would be something like this, or this. Incorrect ways would be something like this because I changed the length, or something like this because now it's pointing in the wrong direction, or something like this. It's the right length, but the wrong orientation. So if I start drawing a whole bunch of vectors, I need to be able to tell them apart. That means I need to label them. But how do you label a vector? Well, in textbooks, when you see a vector, it's usually going to be labeled with an uppercase or lowercase bold letter like this. In handwritten work, since it's hard to draw a bold letter, instead, when you draw a vector, you can label it by putting a little arrow over it, either like this, or maybe something that looks like this. How do you denote the magnitude of a vector? Well, if I have a vector A, I can denote the magnitude by putting bars around the sides, like absolute value bars, like this, or I can just write the letter that I used for the vector without making it bold, like this. So for example, a Rottweiler trots 2 meters to the east. I would draw the vector pointing to the right, like this, and I could label it with a bold B, and if I wanted to label the magnitude, I could write it like this, B equals 2 meters.